Thanks for joining me, and morning, Evie, and thanks for last night. There was one point that I remembered by the time I was speaking to Evie, but forgot to mention to most of you last night. The unit tests are, in theory, sort of relating chapter by chapter with mechanics, but I was just about to issue the unit test for chapter 7 when I realized, yes, there was like a classic sort of ladder question on it. Will this ladder slip or not, sort of type thing. But other than that, it was full of vector stuff. Okay, pretty easy vector stuff, but vector stuff which is sort of chapter 8 stuff. So I think what I'm going to have to do is we'll finish chapter 8 first, and then I'll issue both the chapter tests at the same time. Okay, so I don't know why they've spilled so much through, but that's the way it is. So we're left with chapter 8, and this is a nice one. Okay, it's we start off by just looking at vectors in the context of SUVAT, and that's what we'll be doing today and tomorrow. And then when we come back after half term, you can see on there, we'll be moving on to variable acceleration again. So that's just calculus. That's just integrating and differentiating and then bringing vectors back into play. So, you know, we're on the home stretch now with regard to mechanics, as I was saying last night. So we're going to just start off where we've got no acceleration. It's constant acceleration, not no acceleration, constant acceleration. So that's where SUVAT comes into play. So let me just, if you could just look at, just wait for the slide to pop across. There we go. If you could just start off by looking at the bit in green in the bottom right hand corner to start with. So SUVAT, as we know, S is displacement, U and V are the initial acceleration and the final acceleration. Initial velocity and final velocity, and A is the acceleration and T is time. Now, the first four, they are all vectors. They can have direction. Okay, so throughout this part of the chapter, those four can be vectors, or they can be in the IJ format. Okay, now with all of these, you might have to go and work out the vectors, and they might ask you. The question might ask you for the bits in red. They might ask you for the distance or the speed or the magnitude of the acceleration. So to get those, you need to turn it into the scalar form. So you just Pythagoras the vector, and that will give you the distance, the speed, or the magnitude of the acceleration. T, of course, is scalar. That doesn't have direction. Okay, now this first formula that they are mentioning here, R equals R0 plus VT. Now, for some reason, when we get onto vectors, we tend to use R rather than S for displacement. I don't know why, but so really wherever you see R, we're talking displacement. Okay, now R0 is where we start from. Okay, so that's a position, and so this formula here, imagine you're at R0. You then travel in a particular direction at a constant speed for a period of time. You then end up at your final location, and that is what R is. Okay, and if you're just trying to link this in with SUVAT, this is where we've got constant velocity, constant speed. Okay, so the acceleration is 0. So for the point of view of just linking it in with your SUVAT knowledge, link it. Oh, it's just crashed. I've just literally, it's just crashed the whole. I've lost the work. I'm just going to have to reload it, guys. Sorry. That's annoying. You just have to bear with me while I reload the worksheet, the Active Studio. Right, statistics and mechanics, chapter 8. Okay, so I've got it back, so I just now need to share it. So hopefully it's on its way back. So sorry about that. Let's hope it doesn't do that again. So where was I? Yes, I was saying just linking this in with Suvat, S equals ut plus half at squared on the right. If acceleration is 0, we have a constant velocity, so u equals v. So that's really where that's pretty much what we're saying here. So we then have a pretty straightforward example. Okay, really quickly, if we're just looking at the bit in blue, please. If we start off at the location with the vector 3, 7, and then we're traveling with a velocity of the 2 minus 1 for 4 seconds, 4 times that second vector added together with the first vector means you end up at 11, 3. And then for part B, this is just worth noting, if you're going to end up being due east of the origin, okay, so you're somewhere along the corridor but nothing up the stairs, your J component has to be 0. So that bit that I've just highlighted there in 0, okay? So if you get a question like that, find the time at which the particle is due east, okay? The J component is 0, so that just allows you to then solve along the bottom. So 7 plus t times minus 1 equals 0. So t must be 7. All right, it doesn't matter about the top row. Okay, so that's where we had 0 acceleration, which is what we we're just talking about. That was the constant velocity. So now we're moving on to where we have constant acceleration, so the more typical CVAC. And as I think I said, we're using for some reason r as the displacement. We then have a couple of quite straightforward examples, okay, where we're just using a bit of Pythagoras and a bit of Suvat to work out the angles. We've seen all of that before, and you can see I'm just using v equals u plus at, with u and a being vectors and t being scalar. Now there's quite a long example 3, so I would like you, please, I just think you're just not going to be able to see it on my screen, okay? I've compacted it. It'd be fine if we were projecting it up onto a board at school, but it's not viable for you to read it here. So what I would like you to do, please, before you start the exercise, can you just read through that? And there's some, I think, when particularly, can you just focus on part D? Okay, if you could focus on part D there, but read through the whole thing. That's a very comprehensive example. And that leads us then into exercise 8A. Now, I want us to do this today and tomorrow. So that's our last 2 lessons before half term. And just do the evens, please. Just do the even questions only. Okay, so that's it. So I will stop the recording now. So please work your way through example 3 and then start cracking through exercise 8A, evens only. Thank you.